In this video, we are going to be talking about acid-base reactions, like the basic form of it, because you'll get into that a lot deeper when you talk about buffers and more acid-base reactions in the later chapters. So the first definition of an acid or a base is the Arrhenius definition. So the Arrhenius definition says that acids, when reacting with water, produce an ion called hydronium, which is essentially when an H plus is added to water, or just a hydrogen ion, and an anion, which is for example, in hydrochloric acid would be the Cl minus. It is also called a proton donor, which is not part of the Arrhenius definition. So a base, when reacting with water, produces a hydroxide ion, an OH minus, and a cation. So in this case, you have to note that the acid and base does not necessarily have to contain H plus or OH minus, which is why the Arrhenius definition was altered a little bit in order for you to tell what is an acid and what is a base. So neutralization is when the moles of the acid equals the moles of the base, which you can also say when the moles of the H plus is equal to the moles of the OH minus. So the pH does not necessarily have to be 7 like water is neutral, but in this case, acid or a base reaction could be neutral at pH of 12 or a pH of 3. So in this example is a good example of the Arrhenius definition because it says NaOH, which is a strong base. Depending on what class you're in, you might have to memorize what's a strong base and a strong acid. When reacted with water, produces Na plus, sodium ion, and a hydroxide ion. So this is a great example of when a base reacts with water, it produces an OH minus, so it's an Arrhenius base. So I have this acronym that my teacher taught me, but some people know oil rig, which is a different acronym, but the one I use the most is Leo goes Gur. So when you write this out, Leo would stand for loses electrons oxidation and gain electron reduction. So this can be tested in many of your problems that you have to do, similar to redox reactions, which there's a video on if you want to go check that out. And you just generally have to know when something is being oxidized or reduced. So if it's losing electrons, it's being oxidized, and it's when it's gaining electrons, it's reducing. So if it releases an H plus, for example, if you have HCl and it is releasing its H plus, it's gaining electrons because it's losing something more positive. So then it is being reduced. So Bronsted-Lowry is a little bit of an alteration to the Arrhenius definition, which I talked about earlier. So a Bronsted-Lowry acid is defined as a proton donor. So you can see in this photo that this would be the Bronsted-Lowry acid because it reacts with the B minus and forms A minus, which means the hydrogen has been taken off of that acid and given to the other conjugate acid, which means it's a proton donor because it's taking its hydrogen and giving it to something else. And in the other terms, the Bl base is the proton acceptor because it originates as a B and then turns into Hb plus. So it's becoming more positive, therefore it's a proton acceptor. You can also apply the rules of oxidation and reduction to it. So since a Bronsted-Lowry acid is losing a proton, that means it is becoming more negative. So it's gaining electrons, so it's being reduced. This is a little bit hard to wrap your head around, but I'm sure if you do a few problems on it and practice a few half reactions like we did in our redox video, you'll be sure to figure it out. Thanks for watching.